At this precise moment, on a planet far, far away, an alien sunrise ushers in a new day. But will alien eyes gaze upon it? Or will it go unseen? Just another moment in a vast, sterile universe. The hunt is on for the answer. The Milky Way. Hundreds of billions of stars. Spread across 100,000 light years of space. Among them, the Sun. With 8 planets orbiting around it, including our home. Until very recently, these were the only worlds we knew of, the only planets we could hope to explore for signs of life beyond Earth. Over the last few decades, multiple missions have explored our solar system's planets. And even some of their moons. But to date, even as we continue to look, no convincing evidence of life has been found on any of these worlds. Earth remains one of a kind. The only living world around the Sun. But as the exploration of the solar system continued, another search had begun. For worlds that lie far beyond these shores. You know, the wonderful thing about astronomy is that as we develop better and better technology and accumulate more and more knowledge about our universe, we turn more and more of these points of light in the sky into worlds. I mean, that we've known is a world for a long time, because that is the planet Mars. But just above Mars tonight is a constellation called Pegasus. This is the square of Pegasus. And we now know that around there is a star called 51 Pegasi, which has a planet orbiting around it, a gas giant about the size of Jupiter that goes round that faint point of light every 4 days. It is wonderful to think that in my lifetime, in fact in my adult lifetime, in the last 25 years, we've gone from a universe that could have been devoid of planets beyond our solar system to a universe that we know is teeming with places that we can search for life. Over the last 3 decades, some of the most powerful telescopes on Earth have joined the hunt. Searching for planets unimaginably far away. hiding in the dark. Planets like 51 Pegasi b, the first world outside our solar system to be detected around a sun-like star. "51 Pegasi b is a gas giant, around half the mass of Jupiter, but far closer to its star. Just imagine what that world might be like. A world with skies torn by titanic winds. Where its hot interior is bathed in rain of sapphires. In every sense, 51 Pegasi b is an alien world. And we soon discovered that the galaxy is full of planets, unlike anything seen in our solar system. Planets enveloped by fierce radiation. Their surfaces battered and stripped by the high-energy strobing light of their star. Worlds so cold, their atmospheres are frozen solid. Or great swollen planets with the density of styrofoam. And fathomless atmospheres. These discoveries proved that in one sense, we really are not alone. There are other worlds out there, waiting to be explored. We estimate that in the Milky Way galaxy, there are more planets than stars, hundreds of billions of them. That's hundreds of billions of places to look for life. But there's a catch, because not all worlds, by a long stretch, are like this one. The first planets we found appeared too bizarre, too large, and often too close to their stars for living things to survive. To find worlds where life could exist, we needed to look for smaller, rocky planets in orbits further from their stars.
D-minus 10, 9, 8, 7.
We needed to look
6, 5,
for another Earth.
4, 3, 2. Engine start, 1, 0, and liftoff of the Delta II rocket with Kepler on a search for planets some way like our own.
So the hunt moved to space with the launch of NASA's Kepler Space Telescope.
And we have separation.
Searching for Earth-like worlds in the galaxy beyond. Kepler crossed 94 million miles of space until it arrived in a steady orbit around the Sun. From where it looked out with a fixed and clear gaze, to a single patch of sky in the constellation of Cygnus.
What's it?
Exposing its sensitive light meter to the light of 150,000 stars. It began to look for Earth-like alien worlds. Kepler doesn't detect planets directly. They are far too small. They're just specks of dust relative to their parent star. They're also very faint. They don't emit light of their own, so they just glow very dimly in the reflected ambient light of their stars. So Kepler has to detect planets indirectly. You imagine that a moth just flew across the beam of light from the lighthouse. I wouldn't see the moth, but if I had a sensitive enough detector and everything was lined up properly, I might just see the brightness of the light dim. And that is how Kepler detects planets. Imagine there's an alien astronomer in some distant solar system looking back at the sun, and everything's lined up so they see the Earth trace across the face of our star. They would see the light from the sun dim by 1/100th of 1%. It's a tiny amount, but it's enough. And if they saw that dimming was regular, if they saw the star dim once every year, in this case, then they would infer that there's a planet orbiting around the star. With its exquisitely sensitive light meter, Kepler sees only the regular dimming of pixels. Just a few bits of information. But from those bits, astronomers can begin to build a picture of the worlds that dim the starlight. Worlds that might, in some way, resemble our own. Worlds like Kepler 36b. The planet was one of Kepler's earliest discoveries. Orbiting a star similar to our own, we'd found a world that at first glance might seem familiar. Weighing in at around 4 times the mass of our own planet, Kepler 36b was one of the first of a new class of planet, a super-Earth. The Kepler data doesn't just allow us to say there's a planet around that star, it allows us to characterize those planets. So by looking at the precise way that the light fades and then rises again, and the timing between the dips, we can measure the orbit of the planets. And if there are multiple planets in the system, we can even estimate their masses. So the Kepler data allows astronomers to paint a picture of the worlds it discovers. But the more detailed our picture of Kepler 36b became, the less Earth-like this super-Earth appeared to be. It orbits very close to its star, circling once every 14 days. And it has company. A gigantic gaseous companion with an orbit unusually close to its smaller sibling. The proximity of both its star and sister planet allows us to imagine the bizarre conditions that may exist on the surface of Kepler 36b. The planet may be tidally locked, which would mean that one hemisphere always faces the star. On this side, the punishing heat could turn the ground molten, creating rivers of lava that would crisscross the surface. The planet could experience violent eruptions as the gravitational pull of the gas giant triggers intense volcanism. Each time it passes by. But Kepler 36b could also be a planet of ice. Because if it's tidally locked, the far side would face permanently away from the star. And we could imagine a freezing cold hemisphere shrouded in eternal darkness. For now, this is all just informed speculation. But we are beginning to build a picture of these worlds. I mean, imagine a world where the sun stays at the same point in the sky forever. So one side of the planet is in eternal night and the other side in eternal day. And even the twilight strip between day and night, we think, would suffer from extreme conditions. So Kepler 36b just goes to show there's so much more to having a habitable world than just the composition of the planet. There's the details of its orbit and also the nature of the other objects in the solar system that are orbiting around the star with it. Kepler-36b is just one of thousands of planets that Kepler has discovered. We now know, beyond doubt, that our galaxy is home to a diverse collection of alien worlds. Each one of the over 4,000 planets that we've discovered to date is different from all the others. They really are an alien and exotic bunch, and there's certainly no planet that's identical to the planets that we know of in our solar system. And I think that reveals a deep truth about the universe, because although the laws of nature that form the planets are simple and the same everywhere, and the fundamental ingredients out of which the planets are made are simple and the same everywhere, the nature of a planet also depends on the history of its formation and the environment around its parent star out of which the planet formed. And those are all radically different. So each planet has a different story to tell. I suppose in that sense, planets are like human beings. And this wholly unexpected but exciting discovery certainly complicates the search for life. We needed to narrow the search for planets further, but not too far away from their parent stars. Planets at just the right distance for their surfaces potentially to be habitable. Alien worlds with one precious ingredient that makes Earth a living planet. Now you might legitimately ask, can we transfer all the knowledge we have of life here on Earth to planets elsewhere in the universe? Well, I would answer emphatically yes, we can, because the laws of nature are universal. So the laws of physics and chemistry that underpin biology here on this planet will apply to every planet out there in the universe, whether we've discovered it or not. The chemistry of life requires a few basic ingredients: carbon, nitrogen, oxygen, iron. And it also requires a ready supply of high-quality energy from heat within the planets or perhaps from starlight. But life here on Earth also requires one very important fundamental extra ingredient, which is liquid water. Liquid water is a deceptively complicated substance. It's a very powerful solvent, but it also has structures which are constantly forming and disappearing within it, which act as a kind of scaffolding around which biology happens. Organic molecules are orientated by that scaffolding so they can react together. Now, it is certain that every living thing here on Earth requires liquid water to survive. And I would say it is a very good assumption that every living thing anywhere out there in the universe will require it too. The universe is filled with water. Great reservoirs have been detected throughout the galaxy amongst the gas clouds of giant nebulae. But just because water is plentiful, that doesn't mean that it necessarily ends up in oceans on planetary surfaces. Of the 8 planets in our solar system, only one has liquid water flowing permanently on its surface today. An ocean world where, long ago, life began. Around 4 billion years ago, life on Earth would have begun probably in places not dissimilar to this, where there's geothermal activity, a source of energy, in contact with rich concentrations of reactive chemical elements and minerals, but also, crucially, the magical solvent, liquid water. Now, many rocky planets out there in the galaxy will probably have this, but far fewer, we think, will have that, large bodies of liquid water on the surface. So that's why there's a kind of a catchphrase in the astrobiology community, which is, if you want to search for life, follow the water. Whilst life on Earth was evolving, 124 light years away, amidst a collapsing cloud of gas, dust and ice, a small star was born. And the cloud's swirling leftovers condensed to form a brand new world. In 2015, Kepler found a planet orbiting comfortably within its star's habitable zone. More than 8 times the mass of the Earth, K2-18b is a giant. With a powerful gravitational pull. If the planet is rocky, this may have allowed it to hang on to a thick atmosphere. K2-18b might have all the makings of a water world. And the legendary space telescope had Kepler's new discovery in its sights. The most powerful space telescope of them all had joined the hunt. Hubble examined the light from K2-18b's parent star as the planet passed in front of it, and detected what may be a faint signature of water vapour.
Ah.
124 light years from Earth, we may have at last found the evidence of water on an alien world. This was the first observation of water vapour in the atmosphere of a planet orbiting in the habitable zone around its star. So admittedly, measurement of the amount of water vapour in the atmosphere is pretty wide. It's somewhere between 0.01% and 50%. I mean, this is a planet that's a long way away. But for comparison, our planet has a few percent water vapour in its atmosphere. So that observation is important for 2 reasons. One is it is not zero. there is water vapor in the atmosphere. But secondly, if the measurement is at the lower end, few percent of water vapor in the atmosphere, then that is consistent with this world being a planet with oceans on its surface. The nature of this planet is currently the subject of intense scientific debate. The planet may be more like a mini Neptune, a gas planet. But it is possible to dream of a rocky alien world with skies full of clouds, where water droplets collect and eventually fall, feeding vast oceans that cover the surface of a massive planet, a water world. Where the elixir of life is in plentiful supply. K218b is exciting because it's the smallest world with an atmosphere that we've been able to analyse. And we found that its mass and density and composition of its atmosphere and its orbit are consistent with it being a world with water. And it might be a world with oceans on its surface. We don't know for sure, but just imagine what that small, faraway world around a faint red star might be like. Kepler went on to make many more discoveries. Until, in October 2018, it finally ran out of fuel. After 9 years, it had found over 2,500 alien worlds. Showing us just how common potentially Earth-like planets might be. We estimate that there may be around 20 billion potentially Earth-like worlds, that's rocky planets in the habitable zone around the star that may support liquid water on the surface in our galaxy. That is 20 billion potential homes for life. Now, we don't know the probability that given the right conditions, life will begin on a planet, but we do have evidence from our world. What we know is that here on Earth, life began pretty much as soon as it could after the Earth had formed and cooled down and the oceans formed on its surface. So that might suggest that whilst there isn't a sense of inevitability about the origin of life given the right conditions, it might at least be reasonably probable. So I think that there is at least a chance that life may have begun on some, perhaps many, of those 20 billion Earth-like worlds out there in our galaxy. But I think there are two questions about life. One question is about the origin and the existence of microbes, but often when we speak about aliens, what we really mean is not microbes, but complex creatures, indeed things that we can speak to, civilizations. What is the probability there will be other civilizations out there in the Milky Way? Well, again, the answer is we don't know. But there are observations we can make patterns we can see in the Milky Way that might allow us to make an educated guess. We don't know precisely how we highly intelligent, complex creatures came to be here. But we do know for certain that life on Earth didn't begin this way. We are the product of a story that has been playing out for over a quarter of the age of the universe. From microbes to a global technological civilization reaching out for others. For now, at least, we remain surrounded by silence. The messages we've sent out into the cosmos remain unanswered, and the telescopes we use to scan the skies for alien signals remain quiet. Now, that's not to say, of course, that there aren't other civilizations out there. We may have been looking for the wrong thing in the wrong place. But I think the answer to the question of the Great Silence can be found here on Earth. Because here, it took 4 billion years of stability for a civilization to emerge. That is a vast amount of time. And when we look to the other worlds out there in the Milky Way, it's those two things, stability and time, that appear to be very rare commodities indeed. In 2013, the European Space Agency launched the Gaia Space Telescope. Its mission? To survey the stars of our galaxy, the Milky Way. Billions of stars have been mapped. Each star a potential host for alien worlds. And patterns are already beginning to emerge. Not all stars exist alone. Some have company. And bizarre as they seem, Gaia has discovered around 1 million of these binary or multiple star systems. We've known for a long time that binary star systems, and indeed multiple star systems, exist, but we didn't know precisely how common they are. But now we have a huge amount of high-precision data, including the Gaia data, which tells us that around 50% of all Sun-like stars are in multiple star systems, and for more massive stars, that number is 80%. So how does the prevalence of multiple star systems in the galaxy shift the odds in the hunt for another Earth? Could Earth-like planets exist in multiple star systems? And if so, what might their fate be? In 2020, we may have found a clue. A planet the size of Mars, floating freely through the galaxy. A so-called rogue world. But planets can't form alone in interstellar space. So where did it come from? Dawn. Ushered in not by one star, but two. Perhaps the rogue world grew up in a close binary system. Subject to the gravitational pull of two stars. Its orbit may have been unstable. As its parent stars fought to control its destiny. But even in single star systems, the weak gravitational interactions between the planets can change their orbits. Now, in a double star system, the planets are not only subjected to the gravitational pulls of each other, they're subjected to the stronger gravitational pull of another star. So even if a planet gets into a stable orbit, it's very likely that it won't stay in that orbit for long. So in double star systems, the line between order and chaos is very thin indeed. Even subtle changes in a planet's orbit can lead to dramatic changes in climate. And that's why the surface conditions on planets in double star systems may be unlikely to remain stable enough for long enough for intelligent life to evolve. And the changes in the orbits of planets can sometimes be anything but subtle. A close encounter may have given the rogue world a final gravitational kick. Flinging it outwards and releasing it from the grip of its parent stars. Setting it loose. On a journey through the galaxy. Far from the warmth of its stars, any liquid water the rogue world might once have had would have frozen solid. Any atmosphere that once protected it would have frozen out onto the surface. The rogue would have become a world with conditions that no living thing could endure. An entire planet, alone and adrift. Only to be detected by us millions of years later. A small, Earth-like rogue planet, roaming the darkness of space for eternity. This lonely, wandering planet is not a unique world. Although rogue planets are very difficult to detect, it's estimated that there may be over 100 billion of them in our galaxy. Rogue planets might be the most common type of planet in the Milky Way. And although we think most of them were torn away from their stars soon after formation, this does suggest that star systems are not always stable places where complex life could evolve over billions of years. Our hunt for another living planet has only just begun. Yet we've already learned so much. We found our first rocky worlds. Some in the habitable zone around their stars. Some, potentially, with liquid water on the surface. Candidate worlds for future missions to search for evidence of life. But we've also found hordes of bizarre, tortured worlds, orbiting around violent stars. And a multitude of rogue planets, where complex life, as we understand it, seems impossible. Perhaps it's these worlds that hint at the reason why, for now, one planet stands apart. Alone. Our planet seems to have largely escaped the violence, the chaos, and the constant change that seems to characterize a galaxy like the Milky Way. Yes, there's been the odd mass extinction, but there's been an unbroken chain of life here on Earth stretching back 4 billion years. And if that's what you need to go from the origin of life to a civilization, then although there may be billions of worlds out there where life began, there may be very few civilizations. But that's just an opinion. It's an educated guess. And given the profound nature of the question, no matter how educated the guess, I think it would be ridiculous for us to stop looking both inside our galaxy and beyond. For we may have just received the first glimpse of a world beyond the Milky Way. Around 30 million light years away, nestled in the spiral arms of the Whirlpool Galaxy. A world the size of Saturn. A find that marks an expansion of our horizons. The beginning of the hunt for extragalactic planet. The potential discovery of a planet orbiting around a star in another galaxy is something that I never thought I'd see. And it opens up the intriguing possibility that we might be able to explore not only the question, are we alone in our galaxy, but are we alone in the universe? The answer to that question may lie far in the future. We might never answer that question. But I said, the question, are we alone, is profound, because answering it would teach us much more about what it means to be human. Well, I think we become a little bit more human with every world that we explore, because that ability to lay the foundations, to explore questions to which we may never receive answers in our lifetime, questions for our children or our grandchildren to answer, is a fundamental part of what it means to be human. It's a fundamental part of what makes us so special here on this little world, looking up at the stars, whether we're alone or not.